so 5.3, graphs of relations and functions. Okay, what's a relation again?
A set of ordered pairs.
Okay, they look like X and Y, correct? Functions, what's important about functions?
They don't have a repeating domain.
That's right, no repeating. We can say X for the sake of space. All right, so the first thing, what we're doing is everything that you've learned, we're now like actually graphing these things. So the first thing I'm going to teach you is the vertical line test. It can be used on the graph of a relation to determine whether it's a function or not. Okay, so we know that when we're just looking at ordered pairs, we can look at them and tell if it's a function or not because of the x's. We can sit there and look at the list of x's and say, well, yeah, that's a function. There's no repeating x's, correct? Or we can look at it and see repeating x's and say, oh yeah, that's not a function. Well, sometimes they're going to give you a graph. And you can either choose to write down the ordered pairs to see if it's a function or not, or you can just do the vertical line test. Let me turn on the thing. Okay. So, for example, now y'all pay attention. Are you done writing? Sophia, you done writing? Okay, good. So, I'm going to draw a Cartesian plane. And so are, whoops, that's terrible. And so are you. This is my X, this is my Y. Y'all draw your Cartesian plane, then I'll show you what you're going to draw next. Y'all ready? Okay. This is not the graph, and this is what people get confused. This is not the graph, that's the Cartesian plane. But let's say I'm drawing a graph, and my graph looks like this. That's my graph. Okay? Now, some of you, by just looking at this, will be able to tell that it's a function or not a function. Okay? Some of you may be able to. However, some of you will be like, oh, I'm not sure by just looking at it. I need the ordered pairs. I need the ordered pairs. Well, not necessarily. The vertical line test goes like this. So all of you watch. If you can take, and I'm using a different color for this. If you take your pencil, pen, whatever highlighter, and you can draw a line straight down, not angle, if you can draw a line and it crosses the graph, not the Cartesian plane, but the graph in two places, it is not a function. Notice it crosses right here and here. Therefore, it is not a function. Because the vertical line crosses the graph, not necessarily the Cartesian plane, but the graph in two places. Like I could take the same pink highlighter and look at this. I can draw it right here. Does it cross in two places? Yep, right here on the graph and right here. Don't tell me it crosses three places. I have kids get that confused all the time. They want to say 1, 2, 3 or 1, 2, 3. That Cartesian plane is not considered the graph. Does that make sense? So it crossed in two different places. So it's not a function. That's way easier to do that than to sit there and figure out ordered pairs and everything. Sometimes. So yes, by all means on quiz and test, you may definitely do this. What's funny is this is sometimes very confusing for kids. But if you look at it, if I were to do the ordered pairs for, let's say, this right here, the x for this one would be what?
3.
The x for this one would be 3. So do the x's repeat? Yep. This x is 3, and this x is 3, because it crosses right here. So repeating x's. Do y'all see that? Okay. Let me draw another one. Y'all have all this? Okay. I'm going to draw another Cartesian plane. This is my x, this is my y. Now let's say this time, this is my Cartesian plane, not my graph. Let's say this time my graph is going this direction. It is a function. Because if I take a line, and I'm using P, and I draw it anywhere on this graph, I can draw here, here, anywhere. How many places does my pink line cross the actual graph?
1.
One place. It crosses it here, 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 etc. This right here is not the graph, it's the Cartesian plane. Do you see why sometimes kids will get confused? They'll sit there and say, oh, but it crosses twice, here and here. No, that's not the actual graph, that's the plane. So you're only looking at how many times it crosses the graph. So this is a function. Vertical. Franz, I will let your mom know that you are not taking notes. Vertical line crosses graph in one place. just a review real quick, especially since Keith has been gone. If A was a set of ordered pairs, 2 and 4, you're writing this down too, -3 and 6, 2 and -1. I'll let you write it down. Miranda, you're my victim. Is this a function? Matthew, is she correct? Yes, it is a function, or yes, she's correct. Okay. Miranda and Matthew are correct. Why is it, Miranda? Okay, very good. Matthew, do you concur? Okay, very good. It is not a function. I don't care if you understand this, you're writing this down because it's jogging your memory. During the holidays, you have to write more. Your brain is mush. Not a function because there are repeating X's. And don't try to sit there and tell me your brain is not. I've already dealt with 7th grade today. I can tell you right now, it's already happening.
Do we have Thanksgiving break?
See, it's questions like that, right there,
Yes, we do.
that tells me already that your brain, it's gone. It's history. Are you serious? Did you really just ask me if we get off for Thanksgiving?
I didn't know.
See, this is what I'm talking
I
about.
had been wondering when you mentioned the holidays. Like, wait, when do we have a holiday?
It's next week, Morgan.
Okay, awesome.
All right.
You have 9
Okay.
days off.
Now, a little tidbit. When reading your graph, okay? When reading your graph, and I'm not going to write too many words here. Let's say you have a set A. That's just a little example. And yes, you're writing it down because it's the holidays. And the ordered pairs are -2 and 4, and 2 and 3 for some of you it is. All right, so the set of ordered pairs this time are -2 and 4, and 2 and 3. Don't write this out yet. I want you to, as soon as you put this down, put your pencils down or whatever your writing utensil is, and I want you to pay attention first. I don't want to explain this multiple times. No? Okay, write it down. All right, good. Okay, if I were to say, what's the domain? And can someone clarify for Keith, what's the domain? Raise your hand. I didn't say pick up your pencil. Girl in the center. Put your pencil down, thank you. Franz, what is the domain?
The X.
The X. Okay, very good. And what's the range? Chap. Boy in the corner. Okay. So, if I were to list the domains, these are my domains. Okay, absent child, do you see that these are the domains? Do you see this? I don't want to list names as much as possible. Okay, you see this? I have all those followers now, and I had some, I don't want to give anyone's identity away, even though I kind of slipped on the boy in the very back last week. Okay. You do not, remember I said you have to write it least to greatest? Your choice. I'm not going to force you to do this.
Can we write that?
Shh, no.
I was getting texts this weekend.
Shh, yeah, I'm sure. Okay. You write, look, the 2's are the same, correct? Except one's negative, one's positive? Look how you can do it. Ah.
Well,
That means -2 and +2. If that confuses you, don't do it anymore. You may have an Algebra 2 teacher that says, oh no, you have to do it that way. I'm not going to force you to do it. But this is a way of saying there's a -2 and a +2.
Why you gotta do it like that?
You don't. You guys are always wanting to cut corners and write as little as possible. There you go.
harder.
There's your chance to write one less number.
I would never do that. I would write it like
-2, comma, +2.
Yeah.
Okay, guys. Or if you feel better, -2, +2. Does that make y'all happier?
Yes, thank you.
Yes, you may write it now. Thank you, Nick. Okay, go ahead.
What if the set has three relations?
You would only still do negative and then positive. But that's what I'm saying. You wouldn't write negative, +2, negative, +2 and stuff like that. That's what you're asking?
What if we have two +2 and one -2? Do you still write it like that?
Well, you only have to write
Good
one
question.
to do that.
That is a good question.
Wait, but don't you
Maybe
have to
one of my
write one?
followers can comment and answer that question with something other than the stuff that they keep commenting on. It's very inappropriate. Okay, so I'll get back to you on that question because that's a very good question. I do not know the answer to that. All right, so make sure you write this down. And seriously, I get it. There's a lot of math teachers that prefer this. Guys, in all seriousness, if you continue to write it out like this, as long as you don't have repeaters, I'm okay with that. Because you're still showing that you understand what's happening.
Why would you do that? Though? That's
It's just
only
another way of
confusing
writing it.
yourself.
It's just another way of writing it.
Question. Now I'm like when writing we can't
You don't repeat.
write.
Yeah.
So I don't think it would matter if she's saying like, what if we had another 2 and let's say 5? How would you write that? Well, if we can't have repeaters, then it would still, I believe, be written just like this. It wouldn't
You just have
matter.
to remember that you have to. Could you put it? Like,
Because
could
then
you put an exponent or something by the adding sign?
the only thing is though, then it would be hard to tell if it's a function or not. See what I'm saying?
Yeah.
This is proving the point that
This is stupid. So let's stick with this. I hate that because I think in your book it talks about that. Okay, let's stick with this. I'll talk to Dr. Gatt to confirm that because yes, that would throw you off if it was trying to decide if it's a function or not.
But I believe it's better if you actually get used to
I don't know. We'll see. And if someone smarter is watching my YouTube, then they can comment. Okay, let's move on. Does everyone have this? All right. Okay. Here we go. Another thing. An equation is often used to clearly define the values of the range, which is your y, with each, that says each, by the way, that's terrible handwriting, each domain, which is your x. Okay, sometimes an equation is used, or often, to clearly define the values of the range with each domain. Okay, write this down, and then I'm going to have y'all again put your pencils and pens down, because if you pay attention the first time instead of copying, we won't have issues. Okay, so sometimes an equation is used.
What's the W slash
With
Yes, that means width. I'm lazy as well.
You said we cut corners.
I cut corners when I can. And that's each domain X. So if you have your pencil or pen in your hand, I'm assuming you're still copying stuff down. Thank you. Thank you. All right, here we go. Pay attention, Franz, up here. All right. So we're going to use a substitution. Don't write this down. I'll let you write it. Substitution type method. For example, now stay with me, boys and girls. This is how the problem is going to look. It can be even on IXL, it can be in your book. It could even be on like one of those standardized tests. I doubt it, but it could be. So I'm going to write it, and then when y'all get all your freaks out, we can talk about it. So let's say we're about to do, no, you're not writing. No, you're just watching. So A is going to equal, here's my funny little whatever, ordered pair, X and Y, straight line going down. Y equals X plus 2, semicolon, X equals 1, 2, 3, 4. All right, now don't start writing yet. Do not start writing yet. I want y'all to look. This is a formality. Formality. This, put your pencil down. This right here means nothing. You will have, and I'm sure someone will hear my YouTube and say, no, that's not true. Mr. B may say, no, that does mean something. No, it doesn't. You're looking for an ordered pair. That's almost like a reminder of what you're looking for. You're looking for an ordered pair. They're telling you this in the problem. This big line, that's nothing. That's like dividing the rest of the problem. Right here is your equation. Y equals X plus 2.
So then X.
X, they're
That's the
saying,
equation too.
no, they're saying X is going to equal 1. It can equal 2, 3, and 4. So what you're to do is find all the Y. So look back here. An equation is often used, to clearly define the values of the range with each domain. They gave us the domain. We got to find the range. Can someone guess how we're going to do that based on this, chat?
You put one of those numbers into X and then do it over and over for each 4 numbers and you get Y.
Yep.
Yeah.
And we're going to set it up, watch this, in a table. Now your book, don't write it. Your book is going to set it up a little differently. You're going to set it up like I'm setting it up to help you out. This is going to be your Y. So here is your equation. And you're going to put all these X's in here. Our first one's 1, second one's 2, 3, and 4. And then we're going to start substituting. So go ahead and copy that down, and then we will substitute. Because we're basically looking for our ordered pairs, our ranges. Larry, do you have all this? Once you have it, just start substituting your X's right here for this equation. So it'd be 1 plus 2. And Valeria, what do you get?
3.
That's right. This would be 2 plus 2. What do you get, Valeria?
4.
And then 3 plus 2, Franz, what do I get? 5. And then 4 plus 2, what do I get, New? 6. So then off to the side, I'm going to write my order of pairs. Let y'all catch up. Morgan, is this a function?
Yep.
Yep, she says. Why is it a function, Morgan?
Because there's no repeating x's.
That's right, there are no repeating x's. So basically, what y'all did today was look at a graph. And instead of just looking at ordered pairs, today we're looking at different ways to find out if it's a function or not. I can give you a whole set of ordered pairs, and you can look at them and say, yes, it's a function, no, it's not. Or, the circle mapping thing. Okay, now, the first thing we did is I gave you a graph, and y'all learned the vertical line test. All you have to do is look at that, and you can tell. And then the second way of deciding if it's a function is by using an equation. Any questions? That's it. That's all y'all had to learn today. Vertical line test and how to take this, stick it into a table, and make some sense into it.
And that was supposed to be confusing.
Trust me, sweetheart. I have done this so many times that I'll write this and kids are, wait, what? That's why I now know. Make everyone put their pencils and pens down, watch first, and then it's like, oh, okay.
Well, we're special,
What
Miss
does
Rogers.
f of x write?
Yeah, like
Do what?
The book where
Right here?
He does f of x instead of y.
Yes. Okay, so what she's saying is in the book, they have right here f of x. Remember what I tell y'all? What does f of x represent?
Y.
It represents y. We're dealing with a function. So it's the same thing. Okay? Remember that independent and dependent? Y is dependent on x. Okay. Open up your book to page 196 for examples. And then we're going to do a few. And then I'm setting you free. So, page 196. Franz, wake up because you're going to slow us down. Then everyone's going to have homework. Let's look at number 1. That graph. And all they're saying is the graph relation a function? Is the graph relation a function? Matthew,
Yes.
how do you know?
Well, if you draw a line to the dot, and then you go down, do the vertical line test,
If,
then none of them are like, what did you call it? None of them cross in two places.
there. This is the graph in your book. I graphed it last year. If I were none of these dots, you notice there's no line. You can connect them if it makes you feel better. But notice none of these dots share an X. See, none of them share an X. And like Matthew said, you can draw a line through one of the dots. It's not going to hit any of the other dots. And the lines have to be vertical, by the way.
Wait, then why'd you draw horizontal earlier?
I haven't. the graph, all the pink lines have been straight up and down. That's okay. I'm glad you asked, because I don't want you sitting there confused. Does everyone see that? All right, cool. Number 3. Valeria, what do you think?
No.
You're correct. Because you can literally draw a line, vertical line, through 2 of those dots at the same time, correct?
Yes.
Yep. Does everyone see that? Miranda, do you see it? Sophia, do you see it? All right, very good. All right, let's look at 5. Franz, what do you think?
It's a function.
Yes, very good. Again, because you can draw the line straight through it one place. Now remember, if they just have dots on the graph, as long as the line can't go through 2 dots at the same time, you're good to go. Any questions? Y'all are probably going to be the first Algebra 1 class to fly with this. And even if you're struggling, you're still doing way better than the past. Just saying. Y'all are very special.
There you go.
All right, does everyone have this? And again, if you're sitting there lost, don't sit there and think, man, I'm not special. That's not true at all. All right, 7. For each graph relation, state its domain and range and whether it is a function. Okay, look at number 7.
I already told them.
All you're doing is right, and I tell people this all the time. Give me all the ordered pairs. So choose one of those dots and give me an ordered pair.
-2, 0.
1, 0.
Wait, which is it?
-2, 0.
Is it negative? Is it negative 1, 0?
Yeah, it's -1.
0.
Zero, negative
What are we doing?
Okay, he's
Oh, okay, you don't know. Okay.
okay. So what's another one? So we did that one.
0,
0
1.
to -1.
0 to negative 1. Okay, what's another?
Let's see.
-1, -3.
-3, -1.
Wait.
-3, -1.
All right.
-4.
-3, -3.
-3, -3.
And then -4, -2.
What have they got against the positives?
All right. So 7 says for each graph relation stays domain and range first. So I tell my students, write out the ordered pairs first. It makes it so much easier. Then all you have to do is put D. What are my ordered pairs from least to greatest for D? I have a -1, a 0, -1, -3, -3, -4. What do I have first? -4 is first. -3. Do I have 2 -3s? Do I write it twice?
No.
Now what?
-1.
There is no repeats in the domain.
Wait, but that wouldn't be.
There you go. Right? Right?
Right? Sure.
Now, range. Anyone?
-3.
Okay.
-2.
Is this a function?
No.
Not. So I can just say no. So this is your answer, and this is your answer. Be careful with that because they're asking for several things. And it is not a function because right here I have a -1 and -1 in x, and I have a -3 and a -3 in x. Therefore, it is not a function.
Are you gonna go for 9?
9 is next. Okay. Let's do our ordered pairs.
I have a question about this.
Okay.
If you were to draw the line, would you draw it like a zigzag?
You can't. Vertical line test is straight up and down. Therefore, just by looking at that, it is a function. So we know it is a function just by looking at it, because if you draw the vertical line through any of those dots, it does not connect with any other because it's straight up and down.
So the easiest way to do this one is not even draw a line.
No, you can with that one. All right, I'm just going to write this for you to save on time because I think y'all got the domain. -4, -1, 0. This is all the domains for number 9. And range is this because of the repeaters. So for those problems, you have to do multiple answers. Franz, if you're not writing this down, then I will have to count it wrong. No, you're not. Okay, so we're going to skip 11, and we're going to go straight to 13. Thirteen is back at that whole weird way of writing the equation. They have x and y, that straight line. They give you the equation as y equals 3x, and they tell you that the domain is -1, 0, and 1. All right, so what do I do first, Valeria? What's my equation, by the way, Valeria?
Y equals 3 times x.
Perfect. That's your focus right there.
And multiply every number.
Exactly. So we're going to draw our table. Put your equation and you're solving basically for f of x, which is what?
Y.
That's right. It's your y. So my x's that they gave me are -1, 0, and 1. So here's all my x's. So it's 3 times -1, 3 times 0, and 3 times 1. And Valeria, what's my y?
-3, 0, and 3.
So then you write your ordered pairs off to the side, -1, -3, 0 and 0, and then 1 and 3.
Yes.
Now this one says graph the function.
But it's not a function.
Why?
Oh, there's a negative.
So?
No, I was telling her
Oh.
it was negative.
My bad. Got the evidence.
So then it says in the directions to graph. So 0 and 0 would be here. -1 and 1, 2, 3 is here. And then 1 and 1, 2, 3 is there. Look at this. Don't connect the dots. because they gave specific X's. Yes, sir.
So on number 12, is there a difference if it's an open dot?
Yes, because it doesn't include that spot. So if you drew a line through those two dots, it'd only be going through it one time. Does everyone have this down?
So you're saying it's a function?
I'm not telling you what it is. You may have that as your problem. Yes,
Number 10, the dot doesn't cross, but the line does.
that means if you drew a line, it would cross in two places, right?
So is that it wouldn't cross in 2 places.
Oh, number 10? It can, sure can. There's,
Oh, 10? Oh,
yeah. Does everyone have this?
But what you're saying is if it's an open circle, then the dot doesn't count.
Correct.
Okay.
Y'all got it? Okay, one last thing, then I'm setting you free. And I'm not giving you a whole lot of problems. 17, I'm just going to do this one for you. You may want to quickly write down. What if they didn't give us X's? Huh? You make your own. That's right.
You figure it out.
Whoops. You can just do that. You can put y equals, it doesn't matter. So I'm just going to do -1, 0, and 1. So this would be just like before.
-3, 0.
Yep. Your ordered pairs are here. It's just like the last graph. Now, when you're graphing it though, -1, 1, 2, 3, 0, 1, 2, 3. This time you do connect dots. Connect dots because they didn't give specific X's. Okay, so when they don't give you specific X's, you connect the dots.
So it could be a function or not a function.
This is a function.
Well, yeah, but if you put
You can make it a
1
function.
and then 0, then 1, then it wouldn't be a function. But if you put -1, then 0, then 1, then it is a function.
Wait, what?
Because you're just making up your own numbers.
It's still a function. It doesn't matter what you put over here.
But if you made it to where it wasn't a function.
How can, but this is the like thumbprint.
Yeah, but all you're doing is timing,
-1,
timesing it by the numbers you're making
So
up.
you're saying I could put another -1?
Yeah.
Yeah.
Okay, then it'd be a -3. It's gonna still be on the same graph.
Right, but you can't have repeating, so it wouldn't be a function.
It would be a function because it's on the exact same graph. It wouldn't be a function if it was somewhere else, if it was like right here or something like that. If it's the exact same ordered pair, it's on the same graph, so it is a function.
But it's 2X, it's the same.
Okay, you're not listening. If it's the exact same ordered pair, it's on the same graph. It's the exact same ordered pair. It's not a different y.
What if you did have a different one?
Well, then it wouldn't be it wouldn't be a function. But for 3 times x, it is a function. These are like thumbprints. All right, get started. 2 to 8 even. And everyone's going to be the same. And then 14 through 18 even. Alright, that's 8 problems. No, it's less. 14 through
6.
no, I do that.
It's 7.
There.
8?
What does that say?
20.
So that's 8 problems?
1, 2, 3, 4, 5, 6, 7, 8. Okay. Yeah. IXL, this is due Tuesday. IXL is due Tuesday. Test Friday. Alright, get started. Wait, do what? Yes, everyone. Because of time.
Give us a. Now we have like the
You they don't have a whole lot of time in class. I mean, y'all are only doing that science test. I'll let y'all have class time then, because I know y'all finish it. Lights, please.
I'm worried about the sciences and the vocabulary. I mean, I studied this.
Shh, stop talking. You can get like 3 problems done.